জানার জন্য আমি 5-6 দিন ভিডিও দিতে পারিনি, কারণ তোমরা সবাই যেহেতু ইঞ্জিনিয়ারিং কলেজে মোটামুটি পড়ো, তাই তো তোমরা জানো যে PCA2 আর CA4 এক্সাম অলরেডি বিভিন্ন কলেজে চলছে। আর আমি যেহেতু একটা কলেজের পড়াই, সেই কারণে আমি ওই PCA2 আর CA4 এসব নিয়ে একটু ব্যস্ত ছিলাম, তাই কদিন তোমাদের ভিডিও দিতে পারিনি। তো আজকে ভিডিওর সেকেন্ড পার্ট নিয়ে আলোচনা করতে চলেছি ম্যাকাউট ডিজিটাল ইলেকট্রনিক সলিউশন 2023। আচ্ছা, এটা মোটামুটি সিএসসি ডিপার্টমেন্টে এসেছিল এবং 2023 সালে সিএসসি ডিপার্টমেন্টের কোশ্চেন এটা, কিন্তু এই কোশ্চেনটা আমার মনে হয় যে 2024-এর ফোর্থ সেমিস্টার ইলেকট্রিক্যালের জন্য খুব ইম্পর্টেন্ট। তাহলে চলো শুরু করা যাক। প্রথম কোশ্চেনগুলো দেখে নিই। ডিজাইন the circuit by following proper steps for Boolean expression given below. That is, the D is equal to A bar B bar B in, A bar B B in bar, A B bar B in bar, A B B in, and B not is equal to A bar B bar B in plus A bar B B in bar plus A bar B B in plus A B B in. আচ্ছা, দেখো একটা কথা বলে রাখি, এই কোশ্চেনটা আমরা ডি মর্গানস থিওরেম দিয়ে যেহেতু বলেছে, সেই কারণে আমরা মানে প্রপার বুলিয়ান এক্সপ্রেশন দিয়ে যেহেতু বলেছে, বুলিয়ান অ্যালজেব্রা দিয়ে, সেহেতু আমরা একটা বুলিয়ান অ্যালজেব্রা দিয়ে এটা আমরা সলভ করব। কিন্তু এই কোশ্চেনটা বেসিক্যালি হচ্ছে আমাদের, এটা অ্যাড নেক্সট পেজে অ্যাড করে নিলাম যাতে তোমাদের বহুত সুবিধা হবে। এটা বেসিক্যালি হচ্ছে আমাদের সাবস্ট্রাক্টরের কোশ্চেন, ফুল সাবস্ট্রাক্টরের কোশ্চেন। আমরা অলরেডি আগের দিন ফুল অ্যাডার করেছি, তো যদি ফুল সাবস্ট্রাক্টর এরপরে আমি যদি সময় পাই এই ভিডিওটা শেষে ফুল সাবস্ট্রাক্টরের হাফ সাবস্ট্রাক্টর নিয়ে বলে দেবো। তো বেসিক্যালি চলো আমরা এই আমরা এই এক্সপ্রেশন দুটো করার আগে, সলভ করার আগে আমরা তার আগে তার একটা বানিয়ে নিই, ট্রুথ টেবিল বানিয়ে নিই। তাহলে চলো শুরু করা যাক। তাহলে আমাদের কটা ইনপুট আছে? এ বি বি ইন ইনপুট আর ডি বি নট আউটপুট। তাহলে যদি আমরা একটা এ বি বি ইনপুটে একটা করে নিই, দিস ইজ এ বি B input, and for B naught and D naught we are taking the different color. So this is B and D naught. So this is our table. Now these are the A, these are the A, B and B in. These three are the input and output are the D and B naught. আচ্ছা, D মানে এখানে বুঝবে D means difference and B naught means বড়, যেটা আমরা পাবো কিসে? যেটা আমরা পাবো সাবস্ট্রাক্টরে। তাহলে আমরা 3 ভ্যারিয়েবল মানে কি, কত কম্বিনেশন হবে? 0 to 7 মানে 8টা কম্বিনেশন হবে। তাহলে কম্বিনেশনগুলো লিখে নিই চলো। 2 3 4 5 6 7 8, 0 0 1 1 0 0 1 1, 0 1 0 1 0 1 and 0 1. These are the 4 inputs. Okay, three inputs. Okay, and what are the outputs? আউটপুটটা জানার জন্য আমাদের কি করতে হবে? আমরা একটা মোটামুটি তোমাদের বেসিক বলে দিচ্ছি সাবস্ট্রাক্টরে A B D and B naught. That is, the A means the input is A0 0 0 1 1 0 and 1 1. For that, in this case the 0 0 difference would be 0, 0 1 difference would be 1, 1 0 difference would be 1, and 1 1 difference would be 0. And for this, the borrow should be, for 0 0 when difference is 0, then borrow is 0. When 0 and 1 difference is 0, difference is 1 and borrow is 1. When 1 0, that means the difference is 1 and borrow is 0, and 1 1 difference is 0, borrow is 0. এটা হচ্ছে আমার সাবস্ট্রাক্টরের ট্রুথ টেবিল, এটা মাথায় রাখবে। তাহলে এই হিসাবে তো 0 0 it means difference is, that is the 0 0 out. If you subtract 0 from 0, it becomes 0, and 0 and again subtracted from that 0 again subtracted with this 0, we are getting 0, and borrow is also 0. Then 0 0 becomes 0, and from 0 to 1 it is 1 and it is 1. 0 1 it becomes 1, and 1 0 become 1 and it becomes 1. 0 1 it becomes, that means the borrow is obviously 1 and difference is obviously 0. Okay, it means that 0 1 is borrow is 0, 0 1 is 1, 0 1 it is 1, and from 1 to this 1 it becomes 0. 1 0 the difference is 1, and for 1 0 the difference is 1 and borrow is 0, that means this borrow will be 0. 1 0 difference is 1, and again 1 0 the difference is 1, so this become 1. Again 1 0 it means 1 0 the difference is 1, and 1 1 difference is 0, borrow is also 0. Next 1 1 difference is 0, 0 0 difference is 0, borrow is 0. 1 1 difference is 0, 1 0 difference is 1, and borrow become 1. So this is the truth table. Now we can easily solve our expression. So this become 0, numerical 1, 2, 3, 4, 5, 6 and 7. These are the numeral value. Now what should we do? First we are taking the D. So D become, if you write down the D expression for D, this D become what? So where we should find D as 0, that is at position, this one position, then the second position, then the fourth position, and then the seventh position. It means 1, 2, 4 and 7 we are getting 0. So we should write the expression for this. This is one expression, this is another expression, this is third one, this is third one, and this is the fourth one. So for one, it is the A bar, B bar, B in. So it become A bar, a apostrophe জায়গা bar দিচ্ছি, B bar, B in, then plus mean term, it is A bar, B, A bar, B, B in bar, A bar, B, B in bar. মাথায় রাখবে for mean term, it is the sum of product. We should write 0 as bar and we should write 1 as without bar. So A bar, B, B in, then this one is the A, B bar, B in bar, is the A, B bar, B in bar, and last one is the A, B, B in. A, B, B in. Now if you solve this one, now what should we write? We should take, for these two we should take out A bar, and it becomes B bar, B in plus B, B in bar, এটা তোমাদের খুব চেনা expression, plus here if we take out from these and this, if we take out A, and it becomes B bar, B in bar plus B, B in, এটাও তোমাদের খুব চেনা এক্সপ্রেশন। তাহলে কি এটা মানে কি, this becomes A bar and B XOR B in plus which is A, and this become B XOR B in our whole bar. So the final expression become, it is the B XOR B in and B XOR B in whole bar. So it becomes A XOR B XOR B in. একটা সাজেশন দেবো, এই যে এই এক্সপ্রেশনটা আছে, এই এক্সপ্রেশনটা তোমরা যদি কে ম্যাপের সাহায্যে করো, দেখবে কে ম্যাপের সাহায্যে তোমরা চেকার বোর্ড কনফিগারেশন পাবে। কারণ যে চেকার বোর্ডটা যে ড্র করবে, এই চেকার বোর্ডে এখানে হবে এ বি এ, এখানে হবে বি বি ইন। দেখবে এমন পজিশনে সবগুলো থাকবে ওয়ানগুলো, যে তোমরা কোনোভাবেই সেগুলোর কোনো গ্রুপিং করতে পারবে না। ইউ ক্যান্ট মেক আ গ্রুপ with 2 or 4 or 8 or 6 or 8 or 16. So you have to write the checkerboard configuration, that is the A XOR B XOR B. So this is your D. The minimized expression for D is this. Now we should go for the B naught. So for B naught, that is the at position 1 we are getting B naught as 1, at position 2 at position 2 we are getting B naught as 1, at 3 and at 7. That means we are getting 7 expression. So when we are writing B naught, it becomes first A bar B bar B in plus A bar B B in bar plus A bar B B in plus A B and B in. These are for the four expression. Now you should how, so you should A bar B bar B in. Now you just take these over here, so it becomes A bar B in plus A B B in plus A bar B B in bar plus A bar B B in. So now you can take out B in from here, then it becomes A bar B bar plus AB, that means A XOR B bar, plus from here take out A bar B, it becomes B bar in plus B in, so it becomes B in into A XOR B whole bar plus A bar B. So the expression for D is A XOR B XOR B in, and for B naught is B in A XOR B whole bar plus B bar, sorry, A bar B. Now you have to design the circuit. It means, so you have to write the expression. What is the expression? So expression for D was, I think, D become A XOR B XOR B in, and the expression for B naught was, I think, B in for previous A XOR B whole bar plus A bar B, A XOR B, A XOR B whole bar plus A bar B. Now you draw the circuit. So to draw the first one is easy. So you just take one A and this. So if you make XOR, then we are getting A XOR B if this is A input and this is B input. Now this, if this input is fed with another XOR gate having one input A XOR B and another input as B in, then the output become A XOR B XOR B in, that is nothing but the D equals to. So for this white colored circuit diagram, it represents A, the expression for D, that is the A XOR B XOR B in. Now for the second, what is the B in A XOR B whole bar? It means first we have to solve this B in A XOR B whole bar. So first, so this become A XOR B. Now, if you make one NOT gate, then this become A XOR B bar, and if we fed this with one AND gate, then and this AND gate, and if this B in become the another input of this AND gate, then it becomes A XOR B whole bar into B. Okay. Now another part is A bar B. That means if A is making, we are taking this A with another NOT gate. So this become A bar, and if we feed this A bar into another AND gate, and if we take this B simply and feed it to this another input of this AND gate, then it become A bar B. Now these two input we should easily feed with a OR gate, and OR gate, then we get the output become A XOR B, B in plus A bar B. That is the output for B output. So this is the, for this given expression, for this given expression, we, this is the circuit diagram is this. So I think it is very easy for you. Now you go. So first question is solved. Now go to the second. How do you distinguish between positive and negative logic system? Prove that an OR gate in a positive logic system is an AND gate in a negative logic system. It is very easy question. Don't afraid of this type of question. These are the very simple question. You just, you have to practice this question once and you can easily solve this. Okay. So again we are taking this to the next page. So this is our question. How do you distinguish between the positive and negative logic? Prove that an OR gate in positive logic system is an AND gate in a negative logic system. So first we have to know the, what do you mean a positive logic and negative logic? It's very it's simple. So positive logic means, that is, in the digital electronics we are deals with only 0 and 1. Okay, 0 and 1. So 0 means low and 1 is high. It is obvious that you know that in the numerical system 0 is low, 0 is minimum and 1 is maximum. So if you consider positive logic, that is plus VE, then 1 should be obviously high and 0 should be obviously low. That means if in a, it is a battery, then if one side is grounded, this part is 0 and this plate is 1, because it is high potential, it is low potential. So this is your positive logic. Now what is negative logic? If you consider the negative logic, then there is a minus V, then the scenario is just reversed, that 0 becomes high and 1 become low. That means for this is a 0, it become 0, it become high, and this is 1, it become low. Okay, now So that means high means that is the 5 volt plus 5 volt, and this is ground or 0 volt. This is 5 volt and this is plus 5 volt, and this is ground or 0 volt. Okay, so that is a scenario is just reversed. Whatever the positive, the value in the positive logic, that becomes opposite in the negative logic. That is, in positive logic, whatever which one is high in the negative logic, it becomes low, and in positive logic, which one is become low in the negative logic, that one become high. So now, if you go to the second question, prove that an OR gate in a positive logic system is an AND gate in a negative logic system. That means the पॉजिटिव लॉजिक में और गेट जो काम करता है, नेगेटिव लॉजिक में और गेट सेम काम करता है. मतलब एक एंड गेट है, एंड गेट को अगर नेगेटिव लॉजिक में, मतलब मान लो एक और गेट को हम, ये एक और गेट को हम ये 5 वोल्ट और ये 0 वोल्ट में लगा दिए. उसके बाद ये जो आउटपुट आया, सेम आउटपुट यू विल गेट if a AND gate is connected in 0 volt over here and 5 volt over here, then you will get the same output. That is the question. So how should we prove? So first you have to write down OR gate truth table. So if OR gate is what? Y is equal to A plus B. And AND gate में क्या होता है? Y is equal to A dot B. So if A and B are the two input and Y is the A plus B, then it become, so it is 0, 0, 0, 1, 1, 0 and 1, 1. So it means it becomes, taking the another color, it becomes 0 and 1, 1. If any one of these input is high or both the input is high, then it becomes high. It means that if you are going to categorize the in the OR gate in plus V, that is the in plus positive V means 0 means low. So this will low, this become low, this become low. If this become low, this become high, this become high. If this become high, this become low, then this become high. And if this become high, this become high, and this become high. Okay. Now you write plus minus V. Sorry, don't take minus V first. First take plus VE logic and get. What is the truth table for that? There is the A y is equal to A dot B. That means if A and B are to the output, the Y become A dot B. So what is the truth table? I think all of you know. That means only when both the inputs are high, then it is high. So 0, 0, 0, 0, 1, 0, 1, 0, 0 and 1, 1 become 1. That means you are going to write down the logic, so it become low, 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 high, low, high, low, low, high, high, when it become high. Okay. Now you can write the minus VE logic and get. Okay. Now you have to write down the minus V logic and get. So if A and B are the input and Y is equal to A dot B, this is the logic, basic logic of the AND gate. Now write down the simple this thing, that is That is when so this is positive logic AND gate. Okay. Now this is logic negative logic AND gate. So low, 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 high, low, then high, low, low, high, low, low, then high, high, high. This is the basic you get from here. Low, 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 high, low, low, and high, high, high. It means the now if this is a negative logic AND gate, then for negative logic 0 become high and 1 become low. Now in the case of the low, so for negative logic 0 become H and 1 become L. So it become 1 1 1. So 1 this becomes 0, then it become 1, then this is 0, then this is low means 1 and low means 1. This becomes 0. H means 0, H means 0, it means 0. So 1 1 1 1 0 1 0 1 1 0 0 0. Now you compare these two. When all input are 1 1, it is 1. When 1 0, it becomes 1. 1 0, it becomes 1. When 0 1, it becomes 1. 0 1, it becomes 1. When 0 0, it becomes 0. 0 0, it becomes 0. So this is the positive logic OR gate. This is the negative logic AND gate. So both are equal. So hence prove that positive logic OR gate is equal to negative logic AND gate, or negative logic AND gate is equal to positive logic OR gate, vice versa. I think got it. It's a very simple question. Now go to the third question. That is there is the why are NAND and NOR gates called universal gates? Justify your answer with the help of example. That means it's a very simple question. I think all of you already prepared this question, though I can make 2 or 3 gates. So first is why the NAND gate and NOR gate are the called universal gate. So the reason behind it that so these are the only gate by which we can make any kind of logic gates. That means if you have some NAND gate or NOR gate, you can design. You want some output for NOT gate, but you don't have NOT gate. You have NAND gate, or you have NOR gate. You can easily design a NOT operation using that NAND gate, or you can design any operation that is the NOT and or XOR, whatever it is. You can easily design any kind of logic gates using these two NAND or NOR gate. That's why they are called the universal gate. That means the all the other gate, that is the NAND, NOR, OR, and XOR, XNOR, whatever it is, you can design through the NAND and NOR gate only. That is using only NAND gate or using only NOR gate, you can design any gate. So that's why they are called the universal gate. So I think uh, you should clear about this. Now we can take 2 or 3 example and 2 or 3 design. That is the how can we design. That is the first we take NAND gate. First we take the NAND gate. So NAND gate symbol is and उसके साथ एक NOT. This is the symbol of NAND gate. So first NAND to NOT. That means If we give A, we are getting A bar. Just simple, just this is your, if this is A, this is also A, so Y become A dot A whole bar, that means nothing but the A bar. So this is the NAND to NOT. Now NAND to AND. Okay. That means this is your NAND gate. Now connect this with another NAND gate. You are getting A. If A and B are the inputs, then these become AB bar, and again AB bar is fed to the another NAND gate. You are getting AB double bar. So Y, that means AB. So if A and B are the input, we are getting AB. Okay. Now NAND to OR. Okay, that means giving AB and getting A plus B. Very easy. Take one NAND gate, single input NAND gate, second another single input NAND gate, and they are connected with the another NAND gate. This type of question also asked in your final exam Viva also. So if this is A, this is B, so this become A bar. That means the not A bar. This is another not gate. This is the B bar. Now this is become AB bar. That means become, we can write it as A bar bar plus B bar bar. That means the A plus B. Now NAND to OR is complete. Now NAND to XOR. So NAND to XOR. That means we are taking one NAND gate, we are taking one NAND gate over here. Okay. Now these NAND gates are fed. Output of this NAND gate are fed to one input of another NAND gate, and make a tapping and take two leads that should be connected to another NAND gate. Okay. Now these become connected to another NAND gate, and this is your NAND to XOR. That means that to NAND to XOR we need 4 NAND gate. So for NAND to OR we need 3 NAND gate, and for NAND to AND we need 2 AND gate. Sorry, 2 NAND gate. And for NAND to NOT we're taking 1 NAND gate. So 1, 2, 3, 4 are the gate number. Okay. Now if this is A and this is B, this become AB bar, this become A, this become B. So here output is A dot AB bar whole bar. Here is the B dot AB bar whole bar. Then they are fed, and Y become A B bar plus B A bar. That is the A XOR. So very simple. Now simply another trick is the, so NAND to NOR. How should we? So we need 5 NAND gate. Okay, these type of question, one number MCQ questions, MCQ or SCQ questions will be asked that how many gate NAND gate we need to make minimum NAND gate is need to make a NOR gate. So it is answer is 5 because you just make this NAND gate and that is the this is the or XOR gate. So by XOR gate, that means the XOR gate should be the XOR gate should be designed by the NAND gate. That means this is the XOR gate. That XOR gate is fed with one another NAND gate. We are getting Y is equal to A XOR B whole bar. It is very easy. It means that this is your XOR gate. Now take one another XOR another NAND gate and this become Y is equal to A XOR B whole bar. Okay. So NAND to XOR, and if XOR is filled with another NAND and become no X NOR. This is not NOR, this is the X NOR. Okay. So from NOR NAND to not NAND to AND, NAND to OR, and NAND to XOR, and NAND to XNOR we are designing. Now the we can design the NOR to NOT. Now NOR to NOT. Okay. So again same funda. So this is your OR gate, and one bubble makes this NOR gate, not OR. So if this is A, then the output becomes Y is equal to A plus A bar. That means A bar. Now NOR to AND gate. It is we need three NOR gate. So this is one NOR gate. This is another NOR gate. And you feed these to a third NOR gate to getting the AND operation. That means A and B is the input. So this become A bar, this become B bar, and this become Y is equal to A bar plus B bar whole bar. That means A double bar into dot B double bar. That means the AB. That is the A plus B bar is equal to A bar dot B bar. It is we are not we get it from the De Morgan's theorem. Now node to OR gate. That means you just simply make one AND gate using NOR gate and then feed it to the another NOR gate to get the OR operation. That means AND plus this AND plus this the output is AND fed to the this, if this fed to the another OR gate sorry NOR gate, then you get the OR operation. Okay, that means that the output was A bar, so A dot B, then it become A dot B bar. Okay, so NOR to NOT one and NOR gate, NOR to and three NOR gate, NOR to OR three plus this one four NOR gate. Now NOR to XOR. Now NOR to XOR. So how should we design? The design is same like previous one. This one is your NOR gate, then fed this to the another input. So this become now fed this to another NAND gate, sorry, NOR gate, and again to another NOR gate. Okay, so these are the A and B are the input. So this is A plus B bar, and this become again A, this become B. So if you write it, then this become plus A plus B bar whole bar. This become B plus A plus B bar whole bar. Then this become X if this output is X and this output is Y. So X become AB plus A bar B bar, and Y become AB plus A bar B bar whole bar. You can prove it through the De Morgan's theorem. So just not to XOR, we need 5 NOR. Okay, so that's why. So you see that by NOR gate and by NAND gate, we can easily design any kinds of gates. That's why this is called the universal. Okay, now the last question and the most important question is that for an half adder circuit, the uh, following figure, the input is applied at A and B as shown in graphical form. Plot the corresponding sum and carry output on the same scale. So already in the previous class we already discussed about this full adder and half adder. Now this is your this is your question at to next page. So this is your question. So it's very simple. Don't confuse by seeing this half adder circuit. So half adder circuit, I'm again repeating some previous consequences of the half adder circuit. That is, the half adder circuit is used to add single bit number. So what? So these are to the A and B, and this is the sum and carry. It is, if I draw this, so these are the points we have to discuss. These are the points we have to take consideration. That means these 4 points. So if we this is sum. Now, so A is 0, B is 0. A 0, B 0 means sum is 0. Sum is 0. Any doubt? I think there must not be any doubt. So 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 this is sum is 0. Now here up to this A is 1, B is 0. A is 1, B is 0 means sum is 1. Now from here A is 0, B is A is 0, B is also 0. It means this part is 0, because when both are 0, then the sum become 0. So from for this is 0. Now from here A is 0, B is 0. Obviously it is 0. Again it is A is 1, B is 0. So sum is again 1. Here A is 0, B is 1, sum is again 1. Here A is 1, B is 1. That means the sum is 0. So if you draw the waveform for sum, then the waveform should be like this. I think got it. Again I am telling you. Again I am telling you. When A is 0, B is 0, sum is 0, because 0, 0, 0. When A up to this, A is 1 and B is 0. 0, A is 1, B is 0, that means sum is 1. So sum is high. Again from here to here, here this portion, A is 0, B is 1. So A is 0, B is 1. Sum is A is 0 and B is 1. So sum is, I think here we have got a mistake. Here up to here, when A, here A is 0 and B is 1. A is 0, B is 1, sum is 1. So these become, I think these become 1. Okay. So these become 1, I think. So again I'm telling you, when A is 0, B is 0, sum is 0. When A is 1, B is 0, sum is 1. When A is 0, B is 1, sum is 1. When A is 0 and B is 0, sum become 0. So I think taken, we have did a big mistake. So if the circuit diagram, if this diagram is bit wide, then we can easily draw it. But I think you all of you already know how to draw this waveform. Now taking red, okay, taking red. So this is your another one. This is your one column, second column, third column, fourth column, fifth column, sixth column, sixth column, seventh column. We do it minutely. Otherwise, it's a big chance to for mistaken. So when, so these both are 0, it is 0. It's no doubt. Then this is 1 and this is 0. So this is 1. Now this is 0 and this is 1. That becomes, this become 1. Now this is 0, this is 0. This become 0. Now this become 1, this become 0. So this become 1. Now this become 1, 0, this become 1. Again this become 1. And this become 1, this become 0, this become 1. So it is very easy to draw. Don't be confused. As the diagram is bit clumsy, that's why it is possible for not possible for me to draw it properly, but you, I think you know it. So it is nothing but the waveform for sum. Now what is the waveform for the carry? Now again draw another line for carry. This is the carry line. Now you choose blue, yellow color. Now for carry, when A, B both are 0, then carry is 0. So A, B both 0, so carry is 0. It is obvious. Again A 0, A 1, B 0, carry is 0, no problem. Again A 0, B 1, carry is 0, no problem. Again A 0, B 0, carry is 0, no problem. Again this is 1, this is 0, so obviously 0, no problem. This is 0, this is 1, this is 0, no problem. But for this is for this this is nothing but, if you consider this line, if you consider up to this line, that means if you consider here it is, so consider this line, it is, this part is 1 and this part is 1, so 1 and 1 become carry is 1. It means that if you draw the carry line, it becomes here only, choose yellow color, this is the one only. It means this is the diagram for carry. So the diagram for carry is bit easy, because only when both A and B both are the, both input are the high, then only the carry is high, otherwise the carry is 0. But for sum, when A and B both are the 0, then only the sum is 0, and when A and B both are the 1, then sum is 1, otherwise the sum is 1. So again I am telling you, for this is the for carry sum, this is for carry. Again I am explaining you, for A, when A B both are 0, it becomes 0. When A is 1, B is 0, up to this portion it becomes 1. This is 0, this is 1, so this is 1. This is 0, this is 0, that means this is 0. Again this is 1, this is 0, 1. This is 1, 0, this is 1, 1. This is 1, this is 1, this is 1. So this is nothing but the sum, waveform for the sum and carry. I think all of you already prepared the half adder and full adder, and the obviously for the half and full subtractor. So in the next class I will briefly discuss about the full subtractor and half subtractor for 5 to 10 minutes or maximum 15 minutes, and then we will go for the मल्टीप्लेक्सर से. ओके, सो तब तक के लिए पढ़ाई जारी रखिए, क्योंकि PCA2 तो हो गया है, PCA2 का डेट चल गया है, CA4 का क्लास अप टू 10th मई तक CA4 है. CA4 के बाद 14 को फॉर्म फिलअप है, उसके बाद एग्ज़ाम का प्रिपरेशन, और आई थिंक द एग्ज़ाम विल स्टार्ट फ्रॉम 10th जून एंड इट विल फिनिश्ड ऑन 29th जून. सो अच्छा तरह से प्रिपरेशन लेना शुरू कर दीजिए, क्योंकि इतना सारा इस बार सप्ली आ गया है, सब कॉलेज में इतना सारा सप्ली आ रहा है कि अच्छे से अगर पढ़ाई नहीं करोगे तो सप्ली क्लियर करना मुश्किल है. और कोशिश करो कि ताकि सप्ली नेक्स्ट अपकमिंग सेमिस्टर में सप्ली ताकि ना मिले. ओके, तो तब तक के लिए गुड बाय, वी विल सी इन द नेक्स्ट वीडियो.